So this is just a walkthrough of the critical thinking question, just to give you some ideas of how you might approach these. So this one's saying you have a liquid, 3 liquids, and you're given the following information. Liquid A will stack between liquids B and C. Assume that its volume is no greater than 50 mLs and its mass is no greater than 20. You can use a calculator for B, C, and D, but no calculator for letter A. Now, these are pretty simple. To figure out density, it's mass divided by volume. To figure out mass, it's volume times density. To figure out volume, it's mass divided by density. And I'll go ahead and show you the numbers here, and that's kind of what you should have gotten, more or less. But the question comes with liquid A. With liquid A, it says it will stack between B and C. So how do you know, what number to put, whether it's mass or volume or density? Some people try to average these numbers out to get mass, but it won't work because of the restrictions I've placed on the maximum of 50 mLs and the maximum of 20 grams. This doesn't mean you plug in 20 grams or 50 grams. Again, you're not plugging these in to figure out density. You have to use the given information. And I would refer you back to this right here, when we took the liquids and we stack them. And they stack based on density. So you can consider like, this is letter C, this is letter this is letter that. They stack based on density. So you need to know what their densities are. So I'm going to go ahead and highlight it right here. So this was 1.5, this is 1.70. Well, what's this one? Well, it's 1.60. So that's pretty easy because this, so I'm looking at densities here. This 1.6 will stack between 1.50 and 1.70. Now, what about their mass and volume? You just need a number. Okay, so you need a number that's going to equal 1.60 grams per ml. Now, a lot of people overthink this. So just get 2 numbers that are easy to divide that's going to give you 1.60. So I recommend something really low. Again, it cannot be greater than 50 for volume, and it cannot be greater than 20 for mass. What's going to give you 1.60? So I'm going to just do this off to the side. I've probably shown you this already. Again, take an easy number. Look, 2 divided by 1 equals 2. Anything divided by 1 is going to equal itself. So you could pick a mass like 1.6 divided by 1 ml means it's 1.60 grams per ml. That's what it means. You could also do like 16 divided by 10. Any 2 numbers, it doesn't matter what they are, but they have to equal 1.6 grams. All right, what about this one? You have an object and double the volume, but not the mass. Okay, so the mass stays the same. Specifically, what's going to happen to the density? So again, I would just play with some numbers here. I would take something like 4 divided by 4 equals 1 gram per ml. All right, well, what happens if we double? So again, what happens if we double the volume but not the mass? Well, then this is going to turn into 0.5 grams per ml. And so that means that density goes down, but by how much? By what percent? And it doesn't matter what numbers we put in here. So again, this could be 50 and 50. This could be 50 and 100. Again, 50 divided by 50 is 1. 50 divided by 100 gives you half. This could be 500 and 1,000. Okay, it doesn't matter. It ends up being the same thing. So what happens if you double the volume but not the mass? Specifically to the density, what happens? Does it quadruple? Does it get cut in half? Does it multiply itself by 10? Be specific. All right, you measured the volume of a whole soda can. You want to calculate the density of just the liquid inside. How would you do it? Well, 1, you don't want the soda can. So you want just the liquid inside. The easiest one is volume. So I'm just going to, volume is equal to, I'm just going to put grad cylinder. So just take your liquid and put it into a graduated cylinder. Okay, and that's it. You have volume. What about mass? Somebody might say, okay, take the can and weigh it. You don't do that because you want the weight of the liquid, not the weight of the liquid in the can. So go weigh it, and you're going to get the can plus the liquid. Okay, but then you need to weigh the can. Okay, so you need to weigh the can all by itself and subtract that from that total, and that gives you the weight of the liquid. Okay, and now you have mass divided by volume. So just take whatever this is in grams, divide it by how many mLs it is. All right, someone sold you a silver coin. You want to check to see if it's 100% real. How would you do that? Well, don't bite the coin or don't look at it and be like, yeah, it looks like silver. Go to Google and you ask Google what the density of silver is. The density of silver is always going to be the same, 10 grams per centimeter cubed, or 10 grams per ml. So how do you figure out if your coin is in fact silver? Well, pretty simple. The first part is easy. Mass, well, go weigh it. What about volume? It's not a cube, so you use water displacement. I'm just going to put water dis here. Take mass divided by volume. If it equals 10.5, you got a silver coin. If it doesn't, you don't have a silver coin. All right, this one, just make sure you know how to measure the density of a block given a scale. So I'm going to actually give you a scale. Make sure you know how to do it. Measure length times width times height. Make sure that you measure each side. Just don't rotate the block. Like I said, just leave it in place. Measure side to side, front to back, top to bottom. That's it. All right, what about the salt shaker? That stupid salt shaker. It's coming back. So if you put the salt shaker upside down and 200 mLs of water spills out, and you have a mass of 300 grams, what is the density? Well, somebody's going to say, oh, that's easy. You just take 200 divided by 300. That's not the right answer. Okay. If you put it in upside down, there's two things that caused the water to spill out. Okay, and that 200 is equal to the glass plus the air pocket inside. Okay, I don't want the air pocket. I want just the glass. So you have to figure out how to subtract the air pocket. Now, I'm not going to tell you how to do that. You have to figure that out. Like, you have to tell me. You can't just tell me subtract the air pocket. Like, how do you do that in the lab? How do you account for the air pocket? And then whatever this is equal to is the glass. Now, I'm not asking you to come up with an actual number. So I'm not asking you to come up with a number for the air pocket. I'm just asking you, how do you do this problem in the lab? So hopefully that helps you out, and just be ready to go for the critical thinking questions.